or just raise your hand and let me know. I'll let you know, guys. Guys, thank you for coming. I think we kind of have the full house here. Before we start, I think this is the normal due diligence. I would like to do a quick survey of how many of you are here to hear about Docker networking? Oh, nice. Awesome. That's perfect. And before we even go over there, I'll also ask some more questions. I think, let me introduce myself. I'm Fawad Khaliq. I'm an engineer at PLUMgrid, and I work on OpenStack and containers these days. So we at PLUMgrid, just to introduce you guys, we are an SDN overlay company. We provide software-based software-defined networking for OpenStack clouds and containers, and provide microsegmentation for microservices. And if you need more information, please feel free to have a chat with the folks here. Before we proceed, I would like to understand how many of you have really been hands-on with the current networking models in the Docker space right now? And there could be many of them, like just, how many of them like hands-on? Nice. And how many of you have played with the technology like Docker Swarm? Kubernetes? Mesos? OK, cool. The reason I'm asking is because I'll spend time accordingly on these technologies. So the agenda for the presentation for Docker networking is that I'll briefly introduce what are Docker orchestration tools. We'll talk about Docker Swarm. We'll talk about Mesos, and we'll talk about Kubernetes. A quick overview of each of them. Then we go over how the Docker networking has evolved over time. There were early networking modes available, how it was done, and how the evolution has taken place, and what do we have today. And then we'll talk about PLUMgrid's involvement, and we'll go over a brief demo of Docker Swarm using the current networking options. And yeah, that's it. So let's talk a bit about Docker orchestration tools, which are out there right now. There are many of them in the industry, open source, and lots of tools are trying to implement orchestration for Docker containers, application tasks. And there are a bit of differences, but I think at the common layer, all of them are trying to solve problems like scheduling, scaling, availability, service discovery, networking, and upgrades. So the idea behind having a Docker or a container orchestration tool is that if you have a set of hosts and you want to be able to provision your application and tasks without worrying about how to schedule them, without worrying about where they run, and if things go down, they'll be automatically rescheduled, and your application is just available regardless of, without you being worried about, OK, you have to launch a container, you have to give this IP address, and there are multiple instances running or not, they're behind a load balancer, all of those things. This is where a value of having an orchestration rules comes into the picture. And that's where tools like Mesos or Docker Swarm or Kubernetes have been developed, and that's where they add their value. I'll talk about each of them briefly, and also mention how networking is going to be part of them. So let's start with Docker Swarm. So Docker Swarm is like an architecture where you have this notion of a master and slave model, which is pretty much available in most of these orchestration tools. So you have a Swarm manager, which is responsible for doing the scheduling and service discovery. And then you have this notion of a Swarm node or an agent node where you're running Docker daemon, which is actually doing actual provision of containers and connecting them to networks. And then, of course, you have the store where you're pulling images from to actually launch these containers and whatever application that you need to provision. So this is like a high-level view over here, essentially a group of hosts which you want to portray as one and be able to launch Docker containers on top of without worrying about where they go and how they get scheduled. This is all agnostic of, it's not users doesn't have to worry about those complexities. And this is something we'll go over the demo in today's demo. Then Mesos. Mesos is like a generic cluster resource management tool, which abstracts resources like CPU and RAM. And Mesos is capable of doing much more than containers. So In Mesos, again, the architecture is like you have a master and a slave model. The master is responsible for doing the scheduling. Then Mesos has this notion of marathon, marathon is like a framework in the Mesos ecosystem. And Marathon is responsible for managing containers. And in this, you can manage Docker containers or the other ones which are out there available. One thing I would like to point out over here is that in Mesos, as you see over here, in the slave nodes, you see this containerizer. And Mesos model uses this thing called containerizer, which is actually kind of the backend for what type of container runtime that you want to use. And as you see over here, in 2 of the slaves, I'm running Docker containerizer, and 2 of the slaves, I'm running unified containerizer. This is something which is actually evolving in the Mesos ecosystem. And this is like a pluggable architecture in Mesos, where when you launch an application or a task or a group of tasks, you can specify, are you going to use Docker containers, or you will just use processes or some other type of container. And this is where this pluggability comes to the picture. Unified container is something which is under development these days. And the idea behind is that it will be able to support Docker and other technologies under one layer. It's important. The reason I would like to mention over here is because I'll refer to how networking is going to evolve around this area. One thing I would like to mention over here is that Mesos and Docker Swarm and other frameworks, they use distributed key value store to share the state, to discover how the nodes are joining the cluster, how they're leaving the cluster, their information about what kind of, in this model is that you have masters, multiple masters running. So your slaves can discover who your master is and where it is and how to connect to it. I'll go over Kubernetes, kind of a similar model, but a bit more detail over here. So Kubernetes has this notion of a Kubernetes master node, which is running some bunch of services. Then Kubernetes has these minions, which are like slave nodes. And inside these minions, Kubernetes launches these logical units called pods. So pod is like a group of containers. And it's like a minimal deployable unit inside Kubernetes. You can launch containers, multiple containers inside one pod. And each pod provisions or runs some service or a group of services. And they are behind one IP address. We'll talk more about that. Then you have this little thing over here as part of a Kubernetes minion. It's called Kubelet. Kubelet is the actual agent running on each of these minion nodes, which is responsible for, let's say, talking to Docker daemon in this case. And it will provision your Docker containers. Proxy is like a load balancer. C-Advisor is responsible for sharing information about the resources on a particular machine. And all of that goes to the master to be able to figure out how to and where to schedule the containers or tasks and applications. I would like to take a pause here and see if there are any questions. And then, yes.
So what is the difference between these three systems?
Yes. So the question over here is, what is the difference between these orchestration systems? At a fundamental layer, they are trying to do the same thing. However, if you try to go to the second level, the differences pop up in terms of how much they can scale, what kind of flexibility they offer, how they are able to do service discovery, if there is any solution out there or not. So like at the second layer, you would see these differences, level of complexity, flexibility. And this is an open world today. So you might say, my requirement over here is running tasks, not just in container or in some other shape or form as well. Or I would like to run my tasks in, let's say, in some other runtime, let's say, other than Docker. How can you do it? Maybe some framework can offer that, some framework cannot offer that. So like this is where the value add comes in. Then it's about, let's say, in the notion of Kubernetes, they are some difference in the way they provision their applications. So let's say Kubernetes has this notion of a pod. This is where the differences in networking come to the picture. I'm not going to comment on one versus good and what is bad and what is good. But the differences I'm going to just point out over here is that how they provision these applications. And some may provision as a group of containers. Some may provision as single container. And the third layer is, of course, networking layer, which we'll talk about how that differs and how much flexible it is or useful is that for customers or operators to run in data centers and take it to production.
Are any of these relevant for LXD containers?
So the question is, are any of these relevant for LXD containers? So LXD, just to share with you guys, LXD is a wrapper around LXC, and LXC is based on C groups. So LXD is not relevant to these container runtimes. LXD is more towards OpenStack area inside Nova, and the idea behind LXD is to replace virtual machines. And because LXD was rolled out to support features which resonate or which look like virtual machines, like migration or snapshots. Okay. Yes.
You did talk about structured platforms.
Can you please come again?
Sorry, are you going to go over structured platforms like PLUMgrid, OpenShift?
I've given 30 minutes. No. Yes. Okay. Yes.
So the last two nodes are running Docker runtime engine. Can you explain that?
Yes. So the question over here is these last two nodes are running, let's say, Docker runtime. So in this case, Kubernetes is provisioning Docker containers. So the picture depicts that in this node, you launch Docker containers, which Kubernetes will launch that. So this is a logical diagram. And you can provision Docker containers over here. Yes. OK. If there are more questions, we can take them later. I'm going to move on to networking part now, which is the main area. So with networking, there has been some evolution in the networking of Docker containers since the start. So in the early modes, how many of you are aware of Docker Zero Bridge? OK, so few people know. It's been there, there since the start. So it's like a Linux bridge, which is provisioned on your host where you're running Docker daemon, and your containers go and get connected to and have communication with each other or to the outside world. So there were 3 modes supported in the Docker world. There was a bridge mode and host mode and container mode. Bridge mode was actually, again, it was a Linux bridge where your containers would get connected to and be able to communicate with each other. Host mode is that all the containers are actually connected to your host interface, and they would have port-based mapping onto the same IP address, which belongs to that particular host. Then there is a container mode, which was available, where your container could actually get connected to the other container, and actually they share the same network namespace of a particular container, and they all have communication. This is kind of the model which was used by Kubernetes initially, and now they're moving to a better model. That's the early times and quick overview of that. However, it's like the world has evolved, and like last year, Docker introduced a networking model called container network model. This is responsible for defining network resources, how it can be consumed, and to improve it in a way that people can consume it, make it pluggable, and really take it to the next level, so that it really can be used in production. Because you talk about host mode and those bridge mode, there is really a problem in terms of operations, because if you take your data center and you want to deploy that, it's operationally a big problem, because you're going to every single node, provisioning those things, configuring them, making sure they all multi-host and all of those things are there. It's not easy, and operationally it's very difficult. So to improve all of those, libnetwork is a library which is the reference implementation of CNM, was introduced. And the way CNM works is that it has 3 resources. It has this notion of a network sandbox. Network sandbox is like the networking stack of a particular container, in this case, a Docker container. Then it has notion of an endpoint. Endpoint is like an interface of a Docker container, or you can call it a weth pair, which has one inside the network namespace or network sandbox. And then they have this notion of a network, which is like a group of endpoints where containers can talk to each other. This is kind of the definition of CNM, and libnetwork is an implementation of that. And this is specific to Docker Swarm. Or Docker, it works with Docker daemon, and Docker Swarm can abstract it and show it as one. In this model, network looks like a subnet. And the good thing about libnetwork is that you can pass on arbitrary key-valued paths to the backend, or key-value options, so that you can define your own metadata. For example, if you want to implement policies or if you want to implement multi-tenancy or something else based on how you implement networking, you could, libnetwork allows you to pass that information along so that you can make it really more useful. Because capabilities are kept simple, however, advanced features can be passed along. So the way it works is that you have Docker daemon, which has libnetwork plugged to it, and it shows up in Docker CLI. You run Docker CLI, you have Docker network. I'll go over that. And in libnetwork, there are like two kinds of drivers available. There are native drivers, which are open source, which are part of the reference implementation. And there's this driver called null driver. Null driver is like no networking. Provision containers, you don't care about networking because you want to do it manually or you want to run something which doesn't require networking. You could use null driver. Or you could use a bridge driver. Again, it's very similar to the early mode bridge networking. However, this has gone under the libnetwork API. Then you have the overlay driver, which is an evolution or an improvement of a bridge implementation. However, the difference between bridge and overlay is that an overlay is a multi-host network driver, and bridge is single host. Then you have this notion of remote drivers. So libnetwork has this API where you can take different plugins or drivers and put them under libnetwork API and use libnetwork API to specify, use, let's say, PLUMgrid driver or XYZ or ABC driver to provision my networks and attach them to containers. And this is what libnetwork offers. And how this looks like from Docker point of view, you have, let's say, Docker CLI. You could provision a network, create network command, Docker network connect to a container or disconnect, inspect display, and remove and list, etc. I'd like to take a pause here. Any questions on libnetwork? OK. Yes?
Is there any provision to coexist with an existing network topology, or are you going to create always with this Docker?
Can you please come again?
Let's say if you have an existing network topology, whatever subnets and stuff, and you have hosts deployed, and you would like to have the Dockers running, have the Docker running. When you create the Docker containers, be able to take IPs corresponding to whatever range that you allow. Is that possible?
One thing I would like to clarify here is when you say existing network topologies, who deployed those existing networks?
Assume it's there.
But who?
It's a broad environment.
In this environment, containers have to be launched. So in the containers environment, somebody has to provision an IP for a container. So either the existing one has to come from existing Docker networking. So if that's there, and as soon as you introduce libnetwork, there has to be a migration path for that.
I mean, let's say there are some VMs.
Sure, yes. So yeah, maybe. So the question over here is, can libnetwork allow you to have networking coming from different backends? And the answer is yes, because libnetwork allows you to use multiple drivers at the same time. OK? OK. So that's CNM and libnetwork. There are other networking options available as well. Before I go into how orchestration tools use them, and the background is important here, there's another model available. It's called Container Network Interface. And in this model, the idea is that you provision containers, and this is kept simple in a way that you can just plug and unplug your containers from a particular network. And network definition is done in like a JSON file. You point to it, and you're able to connect your container to a particular network. Over here, as you see in the JSON, you can define the type. Over here, it's called bridge or something else. And let's say you put PLUMgrid here or something, or MAC VLAN or IP VLAN or something commercial, and define the subnet for that network, and of course the IPAM driver that you want to use. And when you launch a container, you could actually connect your container to a particular network. Network definition, things like create network, delete network, that comes depends on how a driver or a plugin implements. This is again very similar to CNM. However, there are some flexibilities here on how you can configure it and use it and utilize it. And there's some simplicity in this model. It's not tied to libnetwork. This is kind of in parallel. The reason I want to give this background is because this is also capable of offering networking for Docker containers. So how libnetwork offers, similar to how you're using Consul or etcd or Zookeeper, you can use any of them for key value store in Docker Swarm environment. Similarly, you can use this. However, there is work going on to make it available in all the frameworks. So I'm sure all of you guys must have been waiting for this slide over here. So we got 3 container orchestration tools or Docker orchestration tools here: Docker Swarm, Mesos, and Kubernetes. And let's look at what networking models are available and how are they doing networking today. So Docker Swarm, as went over it, libnetwork is the default option over there. And as Docker Swarm in an abstraction on top of Docker daemon. So as soon as you do Docker Swarm, my host, and run network command, it will, if it's like a multi-host network, it will provision network for all the nodes. So it's using libnetwork over there. In Mesos, it's a bit more complex. I'm going to give a reference to the slide I presented earlier, where there was this notion of a containerizer. So containerizer is what defines what kind of runtime are you going to use. So over here, if you're using, let's say, a Docker containerizer, you could utilize libnetwork. That would work. That already works today. Then let's say you talk about some other containerizer, let's say Mesos containerizer, or let's say a unified containerizer. Based on that, Mesos is introducing this architecture or a notion of network isolator, which is equivalent to a network module or a plugin, which allows you to have different implementations at the backend. And this is where there are 3 parallel implementations going on. One of them is implemented. The other ones are in discussion and implementation phase. So one of the network isolator which is available in Mesos is called IP per container. It's like every container has an IP address, and there's a project in Mesosphere, Apache Mesos, which is responsible for making it happen through a network isolator. It's called net modules. Then CNM, which we just talked about, is also under discussions. That CNM becomes part of Mesos, and networking in Mesos can be provisioned in a CNM model. And the third one is CNI, which I just talked about as well. This is something which is in implementation phases. Since Mesos is huge and there are lots of use cases, lots of containerizer, and based on that, of course, there are different groups trying to implement different things.
So when you said the lib network, you talked about 3 models, right? And two primarily being the bridge and the overlay model. That is native. Does the other 2 models also support overlay?
In libnetwork, bridge and overlay are drivers. So they share what kind of capabilities they have. You can have a remote driver, which is capable of doing networking as good as or better than an overlay or a bridge. So the question was that the bridge driver and an overlay driver, they have some capabilities. Can the other drivers also have something as similar, or what kind of capabilities they have? So the answer was the remote driver, it really depends on what kind of functionality you expose. It's a good question, and I would like to share one more piece of information here. Inside libnetwork, every single driver that you define, a network driver, it has this thing called scope. So a scope can be local or global. A local scope means it's a single host. A global scope means it's multi-host. Okay. Going over Kubernetes. Kubernetes, as I mentioned, yes, you have a question?
I'm struggling to find the difference between CNM and CNI.
Okay.
Because the way I make the comparison is that both have certain kind of a DHCP, like IPAN here Docker has it. In one case it's through JSON, other case through CNI. The models are same. The
Yes.
way the tools is done and implemented are different. So why is that? Why do you need to have so much specific difference like CNM, CNI, and whatever?
Yes. Okay. The question is, what's the difference between CNI and CNM? So in simple words, the difference between CNI and CNM is that CNM works with Docker, and CNI is flexible enough to work with Docker or some other container runtime as well.
I'd just add to that, and maybe you were about to say this about Kubernetes, but 2 months ago, Google announced that they would not go with libnetwork, and this was big contentious, that they were fragmenting
Yes, exactly. And
Sorry.
yes,
CNM
another one?
CNM means CNI API standard, right?
CNM means container network model. The wording is like a bit a bit off here, and CNI means container network interface because they only care about the interface, plug and unplug. In CNM, of course, you create a network. It's just like more power to the user. You create a network. You have an API to define this. It's a good thing about here. In Kubernetes, I talked about kubelet, which is responsible for managing these containers on each of those minions, which talks to Docker daemon here. Let's say if you're provisioning Docker containers. So in kubelet, they have introduced this notion of kubelet network plugins, and they're based out of CNI. So again, as fellow over here mentioned, there are different choices here. People go with them in different shape and forms, again, depending on their use cases. So not commenting on what's good, what's bad. I think depending on where you use them, each of them have their own value, and they are sufficing the needs and use cases which are there, and both of them and all of them are used and adopted in a very well way in the community and operator community. I would like to take a pause here, move towards any questions here. I would like to keep it interactive. Anybody sleeping? I think we were. Yes.
Going to what PLUMgrid does.
Yes, I'm going to go over that. So that's the next part. Maybe you already saw the slides. So let's talk about PLUMgrid's involvement in the Docker ecosystem. As I mentioned, we are an SDN company, and we provide networking for VMs, containers, bare metals, and we have this notion of virtual domains, which are like logical data center, where you can provision any arbitrary network topology and have in-kernel distributed network functions like bridging, routing, load balancing, policies, NAT, anything that you want. And all of this is based out on a technology called IOVisor. And so there's a poster over there called IOVisor. It's a Linux Foundation official project. And this is where PLUMgrid technology is based on top of. And the product that we have is called PLUMgrid ONS. I don't know, maybe it's supposed to be there somewhere. It's called PLUMgrid Open Networking Suite. And this offers this broad range of networking features that any VM or container or bare metal can use in hybrid, multi-hypervisor, multi-cloud, or single container environment. That's kind of a quick summary here. So where's PLUMgrid's involvement in Docker ecosystem? Specific to Docker here, PLUMgrid works with Docker Swarm or Docker as a libnetwork plugin. It's available on this link up. And it uses PLUMgrid ONS, which is built on top of IOVisor. And this offers some capabilities. As the fellow over here asked a question, these remote drivers, PLUMgrid is a remote driver, by the way. So libnetwork plugin with PLUMgrid has some more capabilities than a normal plugin which is out there. It offers multi-tenancy. You can do policies and have an access to these additional advanced features and functionalities in networking space. Then PLUMgrid Mesos. PLUMgrid integrates in Mesos in two ways. Since there are lots of things going on over there, you could integrate PLUMgrid with Mesos using Docker containerizers. Or the work which is going on in terms of network isolators in the community is something also that PLUMgrid is actually involved, and be able to provision networks through using PLUMgrid ONS in the Mesos space. With that, I'm going to give a demo today on Docker Swarm and PLUMgrid. So before, yes.
I know you mentioned your SDN, but what is the SDN for what? Do you guys have a specific target application? Or?
As I mentioned, this is something agnostic of what you run underneath and on top of it. This is like a platform in between. So we don't care what hardware you run. We don't care what application you run on top of that. So you run application on containers or something on VM, or you have a use case which requires bare metal in there. So completely agnostic of the layers on top of and below. And we have several use cases which are completely in different spaces. They all work fine. You can take a telco use case, or you could take a completely application use case, or you can completely take something as a dev use cases. All of them, they need networking. And based on that, you could use subsets of networking from the entire suite that is available. Going over Docker Swarm and PLUMgrid, as I just mentioned, we'll talk about how the integration is done in libnetwork using PLUMgrid plugin. So let's say you have a Swarm cluster over here, Docker Swarm cluster, which has a master node and slave nodes. And the slave node is running Docker daemon. Docker daemon is actually running the main part, which is the networking component. You have Docker daemon, and then you have libnetwork, which is the library implementing CNM as part of Docker daemon. And over there, what you do is that you provision your plugins. In this case, we have provisioned a PLUMgrid plugin as part of CNM or libnetwork. And as soon as this comes up, this registers to our Linux domain socket and shares its capabilities, whatever capabilities it provides. And all the APIs are then, and when you specify the driver, will start sending these calls to a particular plugin. PLUMgrid plugin will take those calls and talk to the PLUMgrid control plane cluster to provision the network elements, which are going to be available in all of your nodes, which are running Docker daemon, so that they are distributed. And the technology that is running on these slave nodes is IOVisor. So you don't have to go to each of those nodes. This is like distributed networking and whatever topology that the provision is there. Yes?
Are you guys building the data and the control plane?
Sorry?
Is the PLUMgrid plugin, can it be both in the data and the control plane?
So PLUMgrid plugin is just a proxy, an API in the control plane part. It's an API proxy towards provisioning these elements in the PLUMgrid cluster. And everything else comes after that, where you actually, once you provision these network elements, then you provision your containers. These containers communicate. The data path comes on the slave nodes where your containers are talking to each other. That's all the packet is going through the IOVisor. The IOVisor, yes, yes. So, well, you'll see that in the demo, how these things comes together in the picture. This is a new concept here. I want to give a quick preview of that before we go into the demo, the last slide. What you see over here is these are virtual domains. This is a PLUMgrid specific concept. Virtual domains are like logical data centers, which allow you to provision arbitrary network topologies, to allow microsegmentation for microservices. In this case, let's say you're launching applications. And what you see over here is there's a domain which just allows you to talk to, let's say, internet. It has a port over there. And then you have a domain, which is a tenant domain. You have, let's say, a router and a network, which has this group of containers attached to it. They can talk to each other, or they can talk to the outside world. And these are like isolated entities. This is what we will be using in the demo. And they also offer multi-tenancy. So with that, in the demo, my environment is 3-node setup. I'm using Docker Swarm latest release. I'm running PLUMgrid latest release, PLUMgrid ONS 5. Over here, what I'm doing is that I have Swarm cluster with Swarm Manager running on one node. I'm running console as the key value store, which allows you to share, which allows these nodes to share each other's state about node discovery. And of course, information about these distributed networks, which are going to be provisioned, multi-host networks. And then Docker daemon is running on each of those nodes. I'll be using Docker CLI for networking operations and launching containers and accessing their consoles. And I'll also be using Docker UI, which is an unofficial project out there on GitHub in this demo. So with that, I think let's quickly go over the demo part. So what you see over here is PLUMgrid console. PLUMgrid console is the user interface for PLUMgrid ONS. And this, what you see over here is Docker UI. Docker UI is the unofficial project, which I'm using over here to show information about the inventory of the Docker Swarm cluster that I have over here. So this is like the dashboard, PLUMgrid console, and I'll also be using the CLI in this particular demo. So with that, I think let's log into the PLUMgrid console to see what we have over there. As a provision, I had 3 nodes. There was a master node, and there were 2 container slave nodes. So this is a PLUMgrid ONS zone running 3 nodes. So you have a zone which is running the control plane, and then you have a node running two nodes running IOVisor, which is the data plane. In the Docker UI, this shows information about the running containers which are in the system right now. Information about what images are there, what networks are provisioned as part of the cluster, what volumes are there, and then information about the entire cluster, what version of Swarm is there, what kind of resources are available in this cluster, et cetera. One more thing that you see over here is that let's go to the CLI, and if you see over here, I'm doing docker sudo docker -h and going to this IP port over TCP. This points to the IP port where Docker Swarm is running and it's listening, so that my commands can go to that guy and give me information about the entire cluster, not just the local daemon which is running here. So in this case, what you see is that it gave me information about the entire cluster. I have 2 nodes running, C node 0 on this IP port and C node 1 on this IP port, and information about what resources are available to vCPUs and memory 2 GB. And then, of course, information about the cluster as well. Now, we'll quickly walk you guys through the virtual domains, how they look like in a running system. So let's say I have a few virtual domains here, an admin virtual domain, which is like the default one. You can choose to make any virtual domain default. Then a tenant T1 virtual domain, which has some network elements pre-provisioned. It's a T1 which has things like security policy, DNS, container group, and let's say a transit domain, which is there to talk to the outside world or for external connectivity. It has a port over there, as you see. So with that, I think let's go over and provision networks through a libnetwork. This is a video. Please, there's seats over here. Please feel free to come. Yeah. So let's do a Docker network ls. This is again referring back to the slide that I had over there. Is that this is standard Docker CLI, which is using libnetwork, and you can use libnetwork to look at the inventory of networks which are available in the cluster. The interesting thing just to see over here is that and going back to the question that one of the fellow had over here, is that there is networks provisioned via different drivers, and some of them have a node name prefixed to them, and some of them don't have that. So the reason they have a node name prefixed to them is why? Because let me ask somebody a question. Maybe you can tell me.
The node name attached to them is from Swarm.
Yes, and why would you have the node name over there?
Because Swarm needs to keep track of which containers are on which
Okay,
nodes.
so the node name is there because they are single host. And if there's no node name over there, it means it's multi-host and available across the nodes. So it's there to keep track that this network belongs to this particular node. And as soon as you have this affinity of a network to a node, which means single host, and if you provision an overlay network, you will not see a node name appended to it because that's something available on all the nodes as part of the cluster. So let's go over there and provision some containers, some networks. So let's do a Docker network create -d. -d is a parameter in the CLI which says the driver that you want to use. This is the name of the driver. In this case, we're using PLUMgrid as a driver. So I use -d driver. I specify the name of the network. Let's say network 1. And as soon as provision it, this talk to PLUMgrid libnetwork plugin, made a call to PLUMgrid ONS cluster. And at that point, it provisioned network. Inside libnetwork, as you see over here, this shows as network 1 without node name prefix, which means it's global. And we should be able to see this available in the networks in the Docker's UI as well. And if we open its details, one more thing I was referring to earlier on was the scope. This has a global scope. And if something is a global scope, it's multi-host. If something is local, it's single host. Then in the PLUMgrid console, you see a network popped up with an empty container group. And this is something, as soon as we provisioned, this got provisioned into this default domain. PLUMgrid is capable of doing multi-host or multi-tenancy using extra tags in there. I'll also walk you through that. Let's go ahead and provision a few containers here. And as soon as we do them, we'll see how multi-host networking takes place for these containers. So I provisioned 2 containers. and both of them are on node 1. So I think that's not multi-host. Let's provision 2 more. And we're hoping that Swarm will provision them on the other nodes via proper scheduling. And I think it did. We have 2 containers running on the node 0 and 2 containers running on node 1. And at this point, they're all attached to the same network as we provision them. And we should be able to see communication happen across them across these 2 nodes via PLUMgrid ONS. So let's go ahead and log into these 2 containers. Let's log into the container. Container 1 running on node 1. And let's log into, if you log in and you see that it has an IP address 10.0.1.2, you guys must be wondering where the IP address came from. I did not specify any IP address while provisioning the containers, the networks. If you do not specify the IPAM configuration, what happens is that libnetwork uses the default IPAM, which is a module available as part of the reference implementation. Or you can choose to specify your own subnet, or you can choose to have a pluggable IPAM as well, depending on how would you like to consume it. Now let's go and log into another container, which is on a different node, container 4. And let's see, it has an IP address 10.0.1.5. And we should be able to have communication across these 2 guys. And let's see how that goes. So woohoo, we have the ping going on. And let's see how that looks like in the PLUMgrid console. So we can look at the container stats here in the PLUMgrid console. What we see over here is I have 4 containers provisioned. I provisioned 4 containers on this network. And 2 of them are actually exchanging some traffic. And we see that the packets are being increased over here, packet transmitted and packets received. And this is only happening for 2 containers because we are pinging them from each other. Then we should be able to see some more graphical representation of how the communication is taking place. There's this notion of tunnel graph, which shows you information or kind of nice graphical view of how what kind of information is flowing and how the connectivity is like, good, bad, or if something is going bad, you'll see right instantly that things are not working fine for network visibility. So let's go ahead and do some external connectivity as part of the multi-tenancy that I wanted to demo as well. So I have a T1 tenant over here, which has a topology provisioned with a router. And then I also have a T2 tenant. So let's go ahead and see how we can utilize libnetwork with PLUMgrid to do multi-tenancy and be able to provision networks in different virtual domains. And know that virtual domains are completely isolated. So like they're completely fault tolerant and isolated, and the other virtual domains don't know about they don't know about each other unless you actually explicitly have a connection. In this example, I am specifying the subnet, as I mentioned before. In this case, you can choose to specify your own subnet rather than rely on the IPAM module to give you the subnet of its choice. So I pick a subnet 172.22.00/24, specify the gateway. And as you see over here, I'm using the domain name -0 equals domain. And this is a PLUMgrid specific tag using arbitrary key value pairs. So it specifies where to schedule your network to. And your network will get provisioned in that particular domain. In this case, let's specify T2. Let's try to provision that. Oh, so you can't have networks with same name. Let's say network 1 already exists. Let's go ahead and provision a network with the, let's say, network 2 name. And as soon as I provision it with success, we should be able to see that this network should pop up in T2 domain that we just created that. And now we should be able to delete it as well. If we remove this guy, it should get removed. This is a demo of how the CLI works. Now let's go ahead and create a network in T1 domain and see how we can have connectivity from outside, from the physical world, towards these containers. So in this case, I'm going to provision in the T1 domain. And the network popped up here. I'm going to connect this network to this particular router, give it, let's say, a default gateway, which I chose before. And This is PLUMgrid console. What I'm doing over here is just to show you that all of this can be done from the CLI or the UI or the API. And this is kind of different options which are available to provision the network topology. And again, this network topology is way rich than what you saw in the CNM, which is fine because things are supposed to be kept simple over there, but then you might have need for an advanced functionality or advanced use cases or things which are not available today. This is where you could have them. Now let's see how we can see how the microsegmentation or security policies work in this scenario, which are distributed, and how the rules can be configured here, and how you can actually block traffic. Because this is one of the areas where I see people talking about, OK, I'm launching my containers, network is there, but how do I ensure isolation? Because I really care about that. And that's where I would like to show a quick, small demonstration of how that works. So let's say if you go to the user interface, we see that there are different groups here. Group 1 can talk to the internet, and internet can talk to the group 1. Everything is allowed. Everything is wildcarded, and nothing is supposed to be blocked. And I also have a DNS instance here if we wanted to use DNS. And I have a container running here, which we can access from the outside. So let's go ahead and see. We should be able to access this container from the outside. So the container that I'm running over here is like an HTTP server. Yes?
Just a quick question. In the UI that you showed,
Yes.
the edges, is that the actual runtime view of the connections that are going on, or is it based on your definition of how the networks are?
This is live data. So whatever you're running over there in the system, you get a state of that.
So the edge means that there's actually some connection between the two groups?
Yes. So the question was, in the PLUMgrid console, the information that you see over here, is it really coming from the live system that you have over there? Is it runtime? And the answer is yes. So whatever you see over there as your topologies, your containers, the containers talking to each other, their packets, all of the information is, of course, runtime. And it's being fetched from that, yes. And yes. OK, so I have an HTTP server running here. I'm going to log into this guy. Let's see its IP address. And let's try to ping from the physical, from the outside world, and see how that goes. And we'll go ahead and change some policies in there to see if the traffic stops and gets allowed, if we allow that later on. So let's see what IP address I have for this guy. The IP address is 192.11.0.2. Let's go ahead. I have another terminal over here, which is sitting in the outside world. So let's go ahead and ping this guy. And I have connectivity from outside. Let's go ahead and block the traffic by changing policies. One more thing to notice over here is that these stats are available, as you asked the question, is a good point. That these stats are actually, this entire topology, you can go ahead and pinpoint and open and look into and inspect stats, like what kind of packets, like how many packets are coming and going back of different types at different links in the topology, which is view of your runtime data. You can, since this is coming from the outside world, let's go over on one of the links over here in this area, and we see that packets are increasing, let's say 522 to 527. So let's go ahead and change some policies here and see if that takes effect on the traffic that the pings that we're doing from outside. So what I've done over here is that I have a policy with the highest priority that my group 1, where my container is being classified, can talk to the internet, and everything's allowed. I'm going to deny that. And as soon as I deny that and I apply these changes, I should be able to go ahead and see that the traffic and the pings that I was doing, they have stopped. And what happened was that this policy went on to PLUMgrid ONS, which transferred onto the IOVisor, which is implementing at the data plane layer, which is distributed across the nodes. So if there are multiple containers running on, it doesn't matter if they're running on one node or multiple nodes. It's all part of the same topology. The policy is being applied in a nice way over there, in an intelligent way, and in a distributed way, so that this takes effect wherever it resides. Let's go ahead and allow that. And we should be able to see the traffic should resume right after that. So let's go ahead and allow this. And as soon as I apply the changes, let's go back to the CLI, and we see that traffic starts flowing again. There's so many things I can cover in a demo, but I already took, I think, most of the time. I apologize for that. I would like to pause here and take any questions, and then we would like to move to the second speaker. Yes?
The policies apply using what backend? IP table rule or?
No, it's not IP table rules. This is PLUMgrid ONS distributed IO policies, which are in kernel. Yes? Yes.
Suppose I want to do some instrumentation of the traffic, say where the dropping are happening or the latency of the round trip to some destination host. What is a good place to see?
Yes. So the question is, I like the question. The question is that suppose there is some traffic is being drawn, and the operator would like to see where exactly that is happening and would like to pinpoint. The answer is that screen over there. On your left side, we're displaying this product called Cloud Apex. So PLUMgrid offers this product called Cloud Apex, which is like a visual view of your live traffic, how the system is behaving, what virtual domain is going through, what kind of traffic pattern. You can define your own thresholds over there that, OK, if something is dropping packets more than this, or if something is processing data more than this or less than this, start flagging that. And it shows you a nice overview. You can go into details, pinpoint right like a NOC-like view, and you'll be able to go to that exact point and figure out what happened. From virtual domain, VM, container, bare metal, all of those things very nicely. Yes?
So all of these stats that you're showing here are exported by the iOS element?
Yes, we have frameworks out there which in a very nice, efficient way. There are like lots of things in between, longer discussion. But yes, in a nutshell, they get exported, and you get to see all of this. Yes?
I have a question is the hairpin effect, right? Two IPs, two different networks on the same host, two different containers, right? Does it have to go through, I don't know, the box that you showed here, PLUMgrid box? Is that where the switching is happening?
No, it's all happening. This is the topology is running inside.
The IOS.
Yes,
So
which is
there's no
on your.
hairpin
There's
effect.
no hairpin effect. This is all distributed.
Okay.
Yes.
And the fourth is, how do you bridge this network with either a physical network or even a VMware network or any other virtual network? Is there a bridging gateway function between this and that?
So the question is, how is this bridge to physical world? There are multiple ways to do that. You could use PLUMgrid gateways. PLUMgrid has this a notion of a gateway to talk to the physical world. You could use VTAP gateways. Or you could have your own integration with some switching vendor, which is in this case VTAP gateways.
Use Arista, do they have to
Absolutely.
deploy anything specific for PLUMgrid, or can we use the Arista existing VTAPs?
Good. So the question is, can we use Arista here? PLUMgrid integrates with Arista, Cumulus, and PLUMgrid is capable of using Arista as a VTAP, and whatever is behind Arista works out of the box as part of ONS. Okay. Any other questions?
Let's go to the.
OK, yes. Let's go to the next one. I would like to hand it over to Tyler, who's able.